Okay, hi class. So right now we're going to be doing section 4.6 about exponential log equations. So let's go ahead and take a look. So again, what we want to solve today is anything that has two exponents equaling each other or two logs equaling each other, and just kind of review the algebra of how we do that. The first thing we're going to do is, in this example, is we're going to use like bases. So let me write that here. So when you have the same base for both of them, then you don't have to do any logs or anything like that. You can just go ahead and solve. And so here I notice that they're both base 2. And if they're both base 2, then that means that they're the same base. So that means that the exponent has to equal the exponent. So this has to equal this. And so then I'm just going to set that. So I'm going to get x minus 1 has to equal 2x minus 4. Okay. And add 1. And you get x is equal to 2x minus 3. And then just do your algebra. So I know you know all how to do that. And so then you get negative x is equal to negative 3, which means x is equal to 3. Okay? And we can always check what that means. So if I check that, then that's going to be 2 to the 3 minus 1. Okay, question mark. Does that equal 2 to the 2 times 3 minus 1? And minus 4, sorry. And you get 2 squared. Does that equal 2 squared? And yes, because 4 equals 4. Okay, so now that we have that, we can do that for any base. Let me move the microphone just a little bit. So we can do that for any base. So for instance, we can do it for right here. Now this looks difficult, but it turns out that, remember, if we divide by 3, that's the same thing as saying 3 to the 2x minus 1. Because that's what 3 on the bottom means. It's like 3 to the negative 1 power, so you subtract it. And so now we can just set like base. So now I know that this exponent has to equal this exponent. And so you get 4x minus 7 is equal to 2x minus 1. And then you just solve how you like. I'll add 7. And you get 4x is equal to 2x plus 6. And last couple steps, subtract 2x, subtract 2x. And then you get 2x is equal to 6, and so you get x is equal to 3. Okay? And again, you can check, because if we check question mark, you get 3 to the 4 times 3 minus 7, question mark, does that equal 3 to the 2 times 3 minus 1? And this is going to be 3 to the 12 minus 7 is 5. Okay, question mark, does that equal 3 to the 5? And yeah, it does. Some big number. I don't know what 3 to the 5 is, but I can do it if I had to. Okay, so I want you to go ahead and try this one. So please pause the video and see if you can do that. And then we'll come back and then move on from there. Okay, and we're back. So this is what I got. So I got x is negative 2, and as you can see here, they had like base. So if they have like base, you can immediately just equate the exponents, and I just solved it out. I got x negative 2, and then I went and checked, and we do get 5 to the negative 4 on the left, and that equals 5 to the negative 4 on the right. Okay, so oops. Now you can do that, this trick, anytime you want, as long as they look like they have the same base. So like for instance, this one, it looks like they have the same, it doesn't look like they have the same base here. 256 is different than 4. But if we think of the powers of 4, it can somehow become a 256. So 4 to the 1 is 4, 4 squared is 16, 4 cubed is 64, and the next one, 4 to the 4th, is 256. So now we have the same base. So right now I'm going to have 4 to the 4 is equal to 4 to the x minus 5. And so now, since they're the same base, I can go ahead and just say that that exponent has to equal that exponent. And so 4 has to equal x minus 5. And then we just do our algebra. And you get x is equal to 9. Okay, so that is how you do that. And again, we can check, but you get 4 to the 9 minus 5 is 4. And so you get 256 does equal 4 to the 4. Yes. So it's all good. Okay, same deal over here. So we have an 8 and a 16. There's no way that those are the same base right now. But I have to think of a base that they both can have, and I don't think that 8 and 16, so I can do a power of 4 here on 16, but there's no power of 4 that's equal to 8, no whole number, you know. So instead what I can do is, well, what's the powers, what can be a power to give me 8? That'd be a power of 2. So I can have 2 here, and 16 also is a power of 2. Alright, so then that looks like that's going to be my base here. And what we have to do is we just simply say, okay, so let me do it over here. 2 cubed is 8. Alright, and so that means this is going to be 2 cubed to the power of x plus 2. And now let's talk about 16. So 16, I think that's going to be the next one. 2 to the 4 is equal to 16. And so this is going to be 2 to the 4. And then we have x plus 1. Okay? So again, because this is 8, this is 16. And you can go ahead and distribute that, and you'll get 2 to the 3x plus 6 is going to equal 2 to the 4x plus 4. Remember, that's how exponents work. If you have exponent to an exponent, you just multiply. And so now they're the same base. And so now we can go ahead and say, okay, now it's going to be 3x plus 6 has to equal 4x plus 4. And I ran out of room, but I'll just give you the answer. The answer will be, what's that, 2, x equals 2. Okay, and then you can go ahead and check your work. Run out of time a little bit, just because I want to make sure we get to the other parts, but also run out of space. But go ahead and check that. I'm not going to have time to check it. And make sure that that works. Okay, so now that we're moving along with that, let's go ahead and finish this page out. So you might think that you can do this whenever you want to do anything, but unfortunately you can't, because you have to remember what we're talking about with the domain of these functions and stuff like that. So let's take a look at this. 2 and 2. Now those have the same base, right? So this is 2 to the x plus 1, and that's equal to negative and just 2 to the first power. So you think that might work, but this actually has no solution. Now why is that? Why? Well, remember we talked about in the last section that if we looked at the graph of 2 to the x, it starts at 0, it's going to be at 1. Let me do it in red here. 0 is going to be at 1, at 1 it's going to be at 2. Like that. And so, excuse me. And it looks like this. So that's 2 to the x. And 2 to the x plus 1 graph would just be moved to the right, so that would just be like here. 2 to the x plus 1. And anyways, these are both exponential functions, and we talked about for all exponential functions, stuff that looks like 2 to the x or whatever, we talked about the range is going to be positive numbers. So this guy has this little asymptote over here. They both have an asymptote at y equals 0. And the graphs are always above it. They're above and they're above. Always above. So what that means is that 2 to the x plus 1 has to be bigger than 0. And so what that means is that if I try to solve this equation, so 2 to the x plus 1 equals -2, well, that's impossible, because 2 to the x plus 1 is always going to be bigger than 0. Always. So that's impossible. Okay. The really easy way to remember is that every exponential function is, the range is positive. So in other words, every single exponential function is going to be bigger than 0. Always. As long as it's not shifted. So there you go. So that has no solution. Okay, so let's go ahead and finish up. We're going to transition now to talk about logarithms. So we're going to use a logarithm whenever we want to solve an exponential equation that doesn't have like bases. So in practice, we don't really use like bases that a whole lot, but it is good to just get practice with the exponent rules. What we really use when we have any exponential problem is we just use a logarithm, because a logarithm undoes an exponent. Just to recap here, logs undo exponents. So let's go ahead and take a look at some practice. So here we got that. So the first thing you want to do, so step 1 on any of these exponential problems, is you want to isolate the exponent. Okay, so what do I mean by that? Let me show you. So here I want to get my hands alone on e to the 2t. So what I'm going to have to do is I'm going to have to divide both sides by 20. Okay, and so I'm going to get 5 is equal to e to the 2t. Let me leave some more room here. E to the 2t. Okay, so that's step 1. Step 2 then is you convert to log form. Okay, and remember what that means for this problem. E is the base, so if I convert this into log form, I'm going to get a log with base e, and yes, I know that's ln, but just bear with me now. Log base e. Okay, what goes in was the answer from before. Right, and then what goes across is 2t. Remember, there's like a triangle, so e raised up to the exponent becomes 5. So e raised up to 2t equals 5. And remember, we talked about log base e that has ln. That's its function equals 2t. Okay, and so then the last step is just solve for the variable. Okay, so the whole reason we do the log form is that you see now I can just simply, I have t almost, I just got to divide by 2. And so if you did it right on this step, you should only have to add or subtract or divide or whatever. So divide by 2, and if you do that, now we have ln 5 divided by 2 is equal to t. Okay, and if you want a number answer, just to kind of help you with the decimal, turn this on, it's going to be ln 5 divided by 2. Oops, don't need that parentheses. There you go, about 0.805. Okay. So please use these examples, these steps, sorry, 1, 2, 3, and go ahead and give it a crack at quick check 2. It's okay if you can't get it right away, but let's take a check, take a try, and we'll see what we can do. And we'll pause the video, you pause it too, and we'll come back and discuss it. Okay, and we're back. So this is what I got. Hopefully you got the same thing. let me walk you through it. So step 1 is right here, where I want to isolate the exponent. So I divided by 3, and after I divide by 3, I get this. So see, what I mean by isolate the exponent is that you should have the base with no number in front. So it should just be base to an exponent, so there's nothing else, no other jazz. So then after you do that, then you want to convert to log form. So that's step 2, or step 2 is over here. Okay, we convert it to log form. Remember, it's going to be ln because it's base e. The exponent goes on the other side, because remember that's what logs do. They separate bases and exponents. It's like a divorce. And then what goes inside is 11/3. And then this is the last step, step 3, where you just divide by 0.5. Okay, and then that's what I get. Now, just again to get us kind of a feeling for what these numbers are kind of looking like. So divided by 3, and then make sure you close the parentheses, and then divide by 0.5. And you get 2.598. I'll just call it 2.6. Okay. So let's get some practice with logs now. So those are all exponential equations. Let's get some practice with log equations. So the first thing we want to do is you want to, so I'll write the steps again. When you have a log equation, what you want to do is you want to, first step is combine logs using the log rules that we learned last time. So let's take a look. Let me show you. So this one is log base 10 of this minus log base 10 of this equals log base 10 of that. Okay, so they're all the same log, so that's good. So the first step is on the left side, I want to go ahead and combine these using log rules. And so step 1, it's going to be log. Now remember, it's something, it's log of something, take away another log. So it's going to be log 3x minus 2. And what happens? Well, it gets divided. So it's divided by 2. Because remember, subtraction, you divide the so I can write the rule again. Remember, it's log A minus log B equals log A over B. And the right side is just log. There's only one log, so there's nothing we can do there. So after you do that, step 2 is then that you, all you do is you just, there's not a whole lot to do after that step. You just, once they have log equals log, so once you have log something equals log something, so I'll call that x and y. Once you have that, then you can immediately say, okay, x has to equal y. So your book calls it the one-to-one property. It just means that if you have a log only on both sides, then that means the inside, which I call the argument, has to equal that. So all that means is, if you're visual, is that this has to equal that. And so I'll do that down here. So that means that we now just have 3x minus 2 over 2 has to equal x plus 4. Okay? And then we're just going to solve from there. So multiply both sides by 2, multiply both sides by 2. That clears out. And you're left with 3x minus 2 equals 2x plus 8. And then you just add 2, add 2. I really should have made more space in these notes, I'm sorry. So you get 3x, kind of like scrunch it in here, 2x plus 10, and last step is you just subtract 2x. And so you get x is equal to 10. Okay? Alright. And let me just show you how you can check really quick here. I would just go back to the beginning, to maybe right here, to the very beginning, and just start plugging in. So that would be log of 30 minus 2 minus log 2. Okay, does that equal question mark? Does that equal log of 14? And the left-hand side, I'm going to get log of 28 minus log of 2, which is log of 28 over 2. And yes, that does equal log of 14, which was the right side. So we're good to go. Okay, so let's do a word problem with that. So unless you read the problem, please read it, and then we'll go ahead and work on it together. I'll pause the video. All right, and we're back. So hopefully you read it, and so this is my function I'm going to be working with. Notice that this is talking about P is population, and T is years. Now be careful. Okay, remember, T is years, but the key word is since 1990. So always label your variables. That helps you. So it wants to know how many years will the population reach 20,000. Okay, so let's take a look. So this is a P equals 20,000, and so we're just set 20,000 equal to the model 1650 e to the 0.5 times t, and all you do is you just subtract. Remember, step 1, you want to isolate the log. Okay, and so then we get, let's take a look. I'm going to have to divide that. 20, 1, 2, 3 divided by 1650. Okay, so 12.1212 sort of. So 12.1212 equals e to the 0.5 t. Okay, so now that's step 1. Just a reminder. We just isolated the exponent. And so now what should we do? Well, step 2 is you then convert to log form. So log form. And so remember, it's going to be log base e. So you're going to have ln. You're going to have 12.1212. Okay, that has to equal the other side, the exponent. Remember, the exponent never goes inside the log. Okay, the exponent and the log get separated. You know, they separate each other, separate the base from the exponent. Okay, and then step 3 is you just go ahead and isolate the variable. Do all your algebra. So it's divide by 0.5, divide by 0.5. Okay, and let's go ahead and so we're just going to divide by 0.5, and you get roughly 24.24. So t is roughly 24.24 years. But remember, that was years since when? That was years since 1990. So the year is going to be 1990 plus 24.24, which, you know, is roughly 2014. 0.24. Okay, roughly. So in other words, you know, between 2014 and 2015, about a quarter of the way through, and so about March. So about March of 2014, that's when the city's going to reach that. Okay. So one thing I think maybe this section didn't have enough of was examples. So I'm going to go ahead and do these now. Now usually I do this offline, and I just sorry, not offline. I usually just do this off video and then post the answers. But some people have been saying that they would like to kind of see some of these, so I'm going to do them real quick. If you think you have enough, and it's been already about 24 minutes. If you think you have enough and you understand the material, no problem. You can just go ahead and leave now and start the homework. But I'm going to do these real quick and see where we get. Okay. So for those of you sticking around, thank you. Glad to be here. Glad you're here. Okay, and so let's go ahead and get started. So again, step one, so here we're trying to solve. So the first step is you just want to say, okay, I got to isolate the exponent. So I'm going to subtract 6, and we get e to the negative 3k. Whoa, what is happening here? Whoa. Okay. What is going on? Okay. We should be okay now. All right. So we get e. You know what, folks? Something is going on with my computer here. Okay. That's what we have to call for this video. I will post these, and please check them out if you need more of them. But I'm sorry, the computer's really acting up right now. Okay, thanks. See you next time.